In the previous lessons, you have learned how to work with fractions and with decimals. Now in this video, you will learn how to evaluate algebraic expressions that involve both fractions and decimals. So I have 6 examples to walk you through. Example 1, you're to evaluate 3xy when x is equal to 2/3 and y is equal to 4/7. Remember, when it says to evaluate, what I'm doing is I'm simply plugging in the different numbers in place of the variables. So instead of x and y, I'm going to put in a 2/3 and 4/7. And remember that when the number and variables are written right next to each other, that means multiplication. So I'm multiplying 3 times 2/3 times 4/7. When I multiply, I can think of this 3 as being 3/1. And when I multiply, I can imagine this line being extended across so that anything on the top can divide with anything on the bottom. So notice the 3's here and here. Those would divide to give me 1/1. So what I'm left with is on the top 1 times 2 times 4, which is 8. And on the bottom, I have 1 times 7, which would be 7. So my answer would be 8/7. And I can rewrite that as a mixed number. So I can write that as 1 and 1/7. Example 2. We have 2 times x over y minus y over z. And you're to evaluate when x is equal to -2, y is 3, and z is 4. So what I do is I begin by plugging in those values in place of the variable. So instead of 2 times x, we have 2 times -2. And then instead of y, we put a 3. The other y, we put a 3 as well. And then z, we put a 4. So for the numerator of the first fraction, 2 times -2 is -4. So I have -4/3 minus 3/4. Now when I subtract or add fractions, I need to make sure that we have a common denominator. So I can think of this as something over 12 minus something over 12. For the first fraction, -4/3, we had to do 3 times 4 to get to 12. So for the top, we do -4 times 4, which would be -16. For the second fraction, 4 times 3 gives me 12. So then 3 times 3 would give me 9. So what I have is -16/12 minus 9/12. And now we have a common denominator of 12, so I can simply subtract the numerators. -16 minus 9 would give me -25, and that is over 12. So my solution is -25/12. Example 3. I have 4x plus 8y, and you are told to evaluate when x is equal to -1.3 and y is equal to 0.2. So all I do is plug in those numbers in place of the variable. So instead of 4 times x, we have 4 times -1.3, and instead of 8 times y, we have 8 times 0.2. So I can multiply -1.3 times 4, and to do that, I just do 1.3 times 4. That gives me 12, carry the 1, and that's a 5. We have 1 digit after the decimal point, so I need 1 digit after the decimal point in my final answer. So that would become 5.2, and it's going to be a -5.2 because of this negative sign. And then 8 times 0.2, that would give me 16, and then the decimal point has 1 digit after it. So for my final answer, I need 1 digit after the decimal point as well. So that would be 1.6. So -5.2 plus 1.6. When I add with different signs, make sure that I subtract the two numbers. So 5.2 minus 1.6, that's going to be 4, 6, 3. So that becomes a 3.6. And then it's going to be a negative because the bigger number was 5, and that was a negative number. So my final answer is a -3.6. Example 4. You are told to evaluate 2x cubed times y when x equals -2 and y equals -1/4. So once again, I just plug in numbers in place of the variables. So instead of 2 times x to the third, we have 2 times -2 to the third. And then the y would become a -1/4. So I begin with order of operations. So I start with my exponents first. -2 to the third power would be -2 times -2, which is +4, times another -2, which would be a -8. So I have 2 times -8 times -1/4. 2 times -8 is -16, and then -16 times -1/4, I can think of that as -16/1 times -1/4. Negative times negative becomes a positive, and then the 16 on the top can divide with the 4 on the bottom to give me 4/1. So I have 4 times 1 over 1 times 1, which would give me 4. So my solution would be 4. Example 5. We have 2y minus 3xy plus 4x, and we are told to evaluate when x equals 1/10 and y is equal to 4. So I plug in numbers. Instead of 2 times y, I have 2 times 4. And instead of minus 3xy, I have minus 3 times 1/10 times 4. And instead of 4 times x, we have 4 times 1/10. So to begin with, 2 times 4 is 8. And then 3 times 4 is 12. So I have 8 minus 12 times 1/10 plus 4 times 1/10. So I can think of the 12 and the 4 when I'm multiplying with the fractions as being over 1. So I have 12/1 and 4/1. So when I multiply, I can multiply the tops together. So I have 12, I guess -12/1, or over 10, sorry, 12/10. Here I have 4/10. So when I combine, I can think of this as -12/10 plus 4/10. So -12 plus 4 would give me a -8/10. And then 8/10 can reduce. That would become 4/5. I can divide the top and the bottom by 2. So from here, I can either do this in my head and see that this would be 7 1/5, or I can work through this and make 8 as something over 5 so that we have a common denominator. So 8 I can write as 40/5. So I have 40/5 minus 4/5. I can subtract. 40 minus 4 is 36. So 36/5 I can write as a mixed number, and that would be 7 1/5. So 7 1/5 would be my solution. Example 6. We have 2x over 2y to the third minus 2x minus 5y. And you are told to evaluate when x is 4 and y is 2. So I can just plug in the numbers. So I have 3 times 4 over 2 times 2 to the third power minus 2 times 4 minus 5 times 2. So 3 times 4 is 12. 2 to the third power is 8. 2 times 4 is 8, and 5 times 2 is 10. So then from here, 2 times 8 is 16, and then 8 minus 10 is -2, and then 12/16 can reduce. I can divide top and bottom both by 4. That gives me 3/4, and then minus the negative would become a plus. So I have 3/4 plus 2, which would be the same thing as 2 3/4. So 2 3/4 would be my solution. And that concludes our lesson for today. We will see you next time.